look at arithmetic sequences. So what is an arithmetic sequence? A sequence is a set of numbers called the terms of the sequence in a specific order. If the difference between successive terms is constant, it is an arithmetic sequence. The difference between the terms is called the common difference, and we represent it with a lowercase d. You can write an explicit formula using the first term, we call that a sub 1, and the common difference, that lowercase d. This will find the nth term of the sequence, which we'll label a sub n. So my formula for this, for writing my explicit equation, is a sub n, which remember, this is whatever term you're looking for, alright, and that's going to be the nth term, equals a sub 1, which is my first term, plus n minus 1, whatever term that is, times my difference, my common difference. Okay, so arithmetic sequence just means it goes up or down by the same amount each time. Alright, so if we're adding 5, we add 5 every single time. If we subtract 2, we subtract 2 every single time. It's only adding and subtracting. We're not multiplying, we're not changing how much, it's not going up by an increasing amount. It's the same thing every single time. Alright, and then we're going to write a formula or write an equation using what we're given. So first, I want to determine if these three are arithmetic or not. So for the first one, to go from negative 3 to 1, I add 4. To go from 1 to 5, I add 4. To go from 5 to 9, I add 4. So I went up 4 every time, so that means it is arithmetic, and my common difference is a positive 4. For the second one, to go from 1/2 to 3/4, I add 1/4. To go from 3/4 to 5/8. So I'm trying to figure out how I got there. So 3/4 as a fraction with a denominator of 8 is 6/8. So to go from 6/8 to 5/8, I subtracted an 8. That alone, because they're different, tells me that this is not arithmetic. Then I'm going from negative 10 to negative 7, so I'm adding 3. Negative 7 to negative 4, adding 3, and negative 4 to 1, adding 3. So this one is arithmetic, and my common difference is a positive 3. Now I want to find the next three terms. So to go from 6 to 12, I add 6, 12 to 18, add 6, 18 to 24, add 6. So that means my common difference is 6. So my next term would be 24 plus 6, which is 30. And then 30 plus 6, 36, and 36 plus 6, 42. Next three terms. For the next one, going 21 to 19, so I'm subtracting 2. 19 to 17, subtract 2. 17 to 15, subtract 2. So my common difference is a negative 2, which means my next term would be a 13, then 11, then 9. And for the last one, negative 1/2 to 0, I'm adding a half. 0 to 1/2, I'm adding a half. And 1/2 to 1, I'm adding 1/2. So my common difference is 1/2. So my next terms would be 1.5, 2, and 2.5. Okay, or you could write that as improper fractions. That would be 3/2, 2, and 5/2. Doesn't matter which. Now we're going to work with that explicit formula. Alright, so now I'm trying to write an equation so that I can plug in any number for whatever nth term I'm looking for. So for this one, I've got 3, negative 10, negative 23, and negative 36. To write the explicit equation, I've got to have the first term, my a sub 1, and my common difference. Alright, and then everything else I just plug in. So my common difference, I'm going 3 to negative 10. That's subtracting 13, 10 to negative 23, minus 13, and negative 23 to negative 36. I subtract 13. So my common difference is negative 13. My first term is 3. It's whatever one we start with. So now I'm going to start filling in my equation. Remember, it's a sub n equals a sub 1 plus n minus 1 times d. So I'm looking for a sub n. A sub 1 is 3. I'm going to leave the n minus 1, and my common difference is negative 13. Now that I plugged it in, I'm going to go ahead and simplify. So I'm going to distribute this negative 13. So I've got 3. Negative 13 times n is negative 13n. Negative 13 times negative 1, positive 13. I can combine 3 and 13. So a sub n equals negative 13n plus 3. This is a linear equation. So if I skip to this fourth bullet, wants to graph the first 5 terms, I can graph this like a line, and I just want to go 5 dots. Alright, so my first one is at 3, which we'll say is right there. Okay, I know my second one is at negative 10, but I could also use my slope. My slope says it's negative 13, so I go down 13, right 1, and now because I don't have a whole lot of room to graph, I'm just going to say that this is negative 10. Right, then I'm going to go down 13 more, and right 1 more, 13 more, right 1 more, and way down there. 1, 2, 3, 4. So here's my first one, second, third, fourth, and fifth. Now this is not drawn to scale at all. So if I'm just graphing the first 5 terms, I would just leave my dots. I'm not worrying about connecting. But if you notice, it is going to be a linear equation. It's a function. It's a line. Okay, I want to find the 15th term. I'm going to find the 15th term by using my formula here. Right, so 15 is my nth term, so that's what I'm going to plug in for n. So I have a sub 15 equals negative 13 times 15 plus 3. So then a sub 15 equals negative 195 and then plus 3. Negative 195 plus 3 is negative 192. So my nth term, my 15th term, is negative 192. And then my last question wants us to find which term is negative 114. So now I want to know which term is negative 114. That means I'm going to be looking for n. Right? So a sub 15 equals negative 192 because I plugged in 15 for n. Now a sub n is equaling negative 114, and I want to know what I plug in. So I'm going to say negative 114 equals negative 13n plus 3. I want to figure out what n is. So I'm going to subtract 3 from both sides. So I get negative 117 equals negative 13n. So to get n by itself, I've got to divide both sides by 13. And negative 117 divided by negative 13 is 9. So negative 114 is the 9th term of this sequence.